Hello, in this video, we'll determine the LINEST output of this dataset with 4 independent variables. So we begin with the LINEST. The LINEST function, we have the data y, the dependent variables, and the independent variables. There are 4 of them. And we'll show the full statistics. Here we have the coefficients, coefficient of the y-intercept, slope 1, slope 2, slope 3, slope 4. And this side we have the column, the standard error of the y-intercept, standard error of slope 1, standard error of slope 2, standard error of slope 3, standard error of slope 4. And we have the standard error of the estimate. We also have the R-squared, also known as coefficient of determination, degrees of freedom, DF statistics, residual sum of square, and regression sum of square. We will calculate each value using the matrix operations. So we begin with the 1x matrix. So we have 1, and the rest will contain the x values, array formula of this range. Now that we have the 1x matrix, we can determine the pseudoinverse using the combination of minverse, mmult, and transpose of this matrix. So we have minverse, mmult, transpose of this matrix, and itself. Next, we multiply the transpose of this matrix to the dependent variables, so the y values. So we have mmult, transpose of the 1x matrix and the y values. Now that we have 2 matrices, we can now multiply these 2 matrices, the inverse and the transpose, to produce the coefficients. So we have this mmult, this matrix, and this matrix. Now we have the coefficients, starting with BO, which is the y-intercept. This is the slope 1, and this is slope 2, and this is slope 3, and this is slope 4. All this matches to the first line. So we have the coefficients. Next, we will use this coefficient to determine the y hat, or the estimated y. We use multiplication of this matrix and the coefficients. So we now have the estimated y hat, which is in dollars. Next, we will calculate the residual sum of squares, which is equal to sum x, sum of the squares of difference between the actual value and the estimate value, or y and y hat. And this matches to our calculations, or LINEST output. Next, we calculate the residual sum of square. But before we do that, we calculate the population, which is rows of the data range. This is equal to rows of the data range. Here our population is 11. And then we calculate the variance of the population y. And from here, we can calculate the total sum of squares, which is equal to population times the variance of the population y. Next, we calculate the degree of freedom of the numerator. So it is equal to the columns of the independent variables. That's 4 because we have 4 independent variables. Next, we calculate the degree of freedom of the denominator, which is rows of the dataset range minus the columns of the dataset range. So our degree of freedom is 6. So this is equal to 6. That's our degree of freedom. Next, we calculate the regression sum of square, which is equal to TSS minus RSS. That is our degree, and it matches to our output, the LINEST output. Next, we calculate the F statistics, which is equal to ESS divided by the numerator all over RSS divided by the denominator, the degree of freedom of the denominator. So we have 459.75, which matches to our LINEST output. Next, we have the R square, or the coefficient of determination. This is equal to ESS divided by the TSS. It is 0.996. That matches to our LINEST output. Next, we calculate the standard error estimate, which is equal to square root of RSS divided by the denominator, the degree of freedom of the denominator, so df. So 970.57, which matches to our LINEST output. Now we can calculate for the standard error of estimate for the standard error values of our coefficients. The standard error value of the y-intercept is equal to standard error estimate times the square root of this value, which matches to our LINEST output. The standard error value of the slope one is equal to standard error estimate times the square root of this value, which matches to our LINEST output. And the standard error value of slope 2 is equal to standard error estimate times the square root of this value, which is 400.066, matches to our LINEST output. So this one matches to our LINEST output. The standard error value of slope 3 is equal to standard error times square root of this value. This is 530.669, matches to our LINEST output. And the standard error for slope 4, standard error estimate times square root of this value. And this matches to our LINEST output. This completes the LINEST multiple regression of 4 independent variables.